Hello everyone and welcome to Lesson 5, Access Controls. In this lesson we're going to explain the role of access controls in an IT infrastructure. Our key concepts include access control concepts and technologies, formal models of access control, how identity is managed by access control, and developing and maintaining system access controls. Access controls are methods used to restrict and allow access to certain items, such as automobiles, homes, computers, and even your smartphone. Your first experience with access controls might have been as a child when you locked a brother or sister out of your room or used a locker at school. Similarly, the key to your car fits only your car, so only you can unlock and start it. The same is true of your house or apartment. Many people also use a special code to unlock a smartphone or a tablet. No one can unlock the phone or tablet without the code. Or maybe you can't view certain channels in your television without a security code. Access control is the process of protecting a resource so that it is used only by those allowed to use it. Access controls protect the resource from unauthorized use. Just as the lock and key systems for your house or car are access controls, so are the personal information numbers or PINs on your bank account or credit cards. Another way to define access controls is that there are mitigations put into place to protect a resource from a threat. However, you should think of access controls. They are tools to make sure that only allowed users can access a resource. Businesses use access controls to manage what employees can and cannot do. Access controls define who users, which are people or computer processes, are, what users can do, which resources they can reach, and what operations they can perform. Access control systems use several methods to achieve this goal, including passwords, hardware tokens, biometrics, and certificates. Access can be granted to physical access such as buildings or rooms. Access can also be granted to computer systems and data. Before an asset can be protected, the protector must know some information about the intended user. The four parts of access control are as follows. First, you have identification. That's who is asking to access the asset. Next is authentication. Can the requester's identity be verified? Next is authorization. What exactly can the requester access and what can they do with it? And next is accountability. How can actions be traced to an individual? We need to ensure that a person who accesses or makes changes to data or systems can be identified. This process of associating actions with users for later reporting and research is known as accountability. These four parts are divided into two phases. The policy definition phase. This phase determines who has access and what systems or resources they can use. The authorization definition process operates in this phase. And second is the policy enforcement phase. This phase grants or rejects requests for access based on the authorizations defined in the first phase. The identification, authentication, authorization, execution, and accountability processes operate in this phase. Access controls generally fall into one of two categories, either physical access controls or logical access controls. Physical access controls control access to physical resources. They could include buildings, parking lots, and protected areas. For example, you probably have a key to the door of your office. This key controls the physical access to your office. Logical access controls, these controls access to a computer system or network. Your company probably requires that you enter a unique username and password to log onto your computer. That username and password allow you to use your organization's computer system and network resources. An organization's facility manager is often responsible for physical access control. This person might give you a security card, also known as a smart card, programmed with your employee ID. You might need to swipe this card through a card reader to open a gate to the parking lot and swipe it in the elevator to let you off on your floor. You might also need to swipe this card to unlock the door leading to your office. This card allows you to enter these locations because you are an employee. The organization's authorization policy grants you, as an employee, physical access to certain places. People without an authorized card shouldn't get past the front gate. If your organization shares your office building with other organizations, you might even have a second card that grants access into the building after hours. These cards control access to physical resources. Security administrators use logical access control to decide who can get into a system and what tasks they can perform. A system can also use logical access controls to influence how staff personnel use a system. Examples of systems control for human resources system include the following. deciding which users can get into the system. HR employees may be the only employees who are allowed to reach sensitive information stored on an HR server. Monitoring what a user does on the system. Certain HR employees might be allowed to view documents, but other HR employees might be able to actually edit these documents. And finally, restraining or influencing the user's behavior on that system. An HR staffer who repeatedly tries to view restricted information might be denied access to the entire system. These permissions control access to logical or system resources. The security kernel is the central part of a computing environment's hardware, software, and firmware that enforces access controls for computer systems. The security kernel provides a central point of access control and implements the reference monitor concept. It mediates all access requests and permits access only when the appropriate rules or conditions are met. For example, the subject requests access to an object. The security kernel intercepts the request. The security kernel refers to its rule base, also known as the security kernel database. It uses these rules to determine access rights. Access rights are set according to the policies your organization has defined. And last, the kernel allows or denies access based on the defined access rules. All access requests handled by the system are logged for later tracking and analysis. This figure shows a request for access coming from the subject to a particular object, in this case a file. The reference monitor intercepts the access request. The access is granted according to the rules in the security kernel database. The rule base might be an access control list, a directory, or another repository of access permissions. If the rules permit the access request, the reference monitor permits access and creates a log entry. An access control policy is a set of rules that allows a specific group of users to perform a particular set of actions on a particular set of resources. If users aren't authorized, they don't have access to security functions or system resources. You use access control policies to reduce and control security risks. Both automated processes and humans use access control policies. You must understand the 4 central components of access control to manage access control policies well. First, you have users. These are the people who use the system or processes that perform some service for other people or processes. A more general term for users is subjects. Resources. Resources are protected objects in the system. Resources can be accessed only by authorized subjects. Resources can be used only in authorized ways. Actions are activities that authorized users can perform on the resources. And relationships, these are optional conditions that exist between users and resources. Relationships are permissions granted to an authorized user, such as read, write, or execute. This slide shows some logical access control solutions. You can use biometrics, tokens, passwords, or single sign-on, for example. The first step to controlling access is to create a policy that defines authorization rules. Authorization is the process of deciding who has access to which computer and network resources. In most organizations, authorization is based on job roles, background screening, and any government requirements. These conditions or policies are decided primarily by either a group membership policy or an authority level policy. The most detailed authorization policy is based on each individual user. In this type of policy, each user has a specific assigned privilege. These user-assigned privileges allow administrators to define approved resources access at a very detailed level. However, maintaining a user-based authentication approach is very difficult. This type of authentication requires a lot of administration time to stay current. Second is the group membership policy. And this authorization is defined by what groups users are assigned to. Assigning group-based privileges reduces the administrator workload by grouping similar users together. For example, perhaps only the security cards of members of the IT department give access to the room where computer equipment is stored. If you're not a member of this IT group, your security card does not let you into this room to retrieve a new monitor. If you want to access the computer equipment storage room, you must first contact the IT department, which likely assigns a member of the IT group to help you. And last is, in an authority level policy, you need a higher degree of authority to access certain resources. For example, perhaps only a senior level member of the IT group has permission to enter the room that houses servers. Servers are often more valuable than computer monitors, so a policy might specify that only a senior staff member can enter the server room. Once you define authorization rules in an authorization policy, you can enforce the rules. Each time a user requests access for a resource, the access control grant or deny access based on the authorization policy. The first step in enforcing an authorization policy is identification. Identification is the method a subject uses to request access to a system or resource. A subject can be a user, a process, or some other entity. There are several methods commonly used to identify subjects. The method you choose depends on your security requirements and the capabilities of your computing environment. In the next section, I'm going to teach you about various methods and guidelines for how a subject identifies itself to a system. So far in this lesson, you've learned about methods to define authorization rules and identify users. The next step is authentication. In this part of access control, the user validates or proves the identity he or she provided during identification. Authentication answers the questions, are users who they say they are? Authentication proves that the subject requesting access is the same subject who has been granted access. Without authentication, you could never really know if users are who they claim to be. Let's take a look at the authentication types. There are 5 types of authentication. You have knowledge, which is something you know, such as a password, passphrase, or a personal identification number. You have ownership, which is something you have, such as a smart card, key, badge, or token. You have characteristics, some attribute that is unique to you, such as your fingerprint, retina, or a signature. Since the characteristics involved are often physical, this type of authentication is sometimes defined as something that you are. Next, you have location, somewhere you are, such as your physical location when you attempt to access the resources. And last is action, something you do or how you do it, such as the way you type on a keyboard. Each type of authentication can be easily compromised on its own. The use of controls from only one category is known as single-factor authentication. Systems containing sensitive or critical information should use at least 2 of these authentication types. The use of techniques from 2 or more of these categories is called two-factor authentication and provides a higher level of security than using only one. Let's start with authentication by knowledge. Authentication by knowledge is based on something you know, such as a password, passphrase, or PIN. Static passwords are those that are seldom, if ever, changed. Passwords are the oldest and most common method of authentication for computer systems. They are also the weakest. You should not use passwords alone to protect valuable resources. As the value of resources increases, so should the strength of the access controls protecting it. Two-step authentication should be the minimum requirement for valuable resources. Attackers often use brute force or dictionary attacks to crack passwords. These methods can easily crack weak passwords, such as those that are very short or contain dictionary words. Your book will tell you about brute force and dictionary attacks, and also will explain password account policies. Let's take a look at password account policies. In addition to encouraging password best practices, your account policy should include clear password requirements. Authentication by ownership is the second type of verification. This is based on something you have, such as a smart card, a key, a badge, or a token. Tokens can be synchronous or asynchronous. Synchronous tokens uses an algorithm that calculates the number of both the authentication server and the device. It displays the number on the device's screen. The users enter this number as a logon authenticator, just as he or she would use a password. In a time-based synchronization system, the current time is used as the input value. The token generates a new dynamic password, usually every minute, that is displayed in the window of the token. To gain access, the password is entered with the user's PIN at the workstation. No token keyword is required. This system requires that the clock is the token remains in sync with the clock in the authentication server. If the clock drifts out of sync, the server can search 3 or 4 minutes on each side of the token to detect an offset. If the difference becomes too great, you must resynchronize the clocks. An event-based synchronization system avoids the time synchronization problem by increasing the value of a counter with each use. The counter is the input value. The user presses a button to generate a one-time password and then enters this password with his or her PIN at the workstation to gain access. One common problem with event-based synchronization systems occurs when a user creates a password using the token but doesn't use the password to log on, and the counter in the server and the counter in the token become out of sync. And finally is continuous authentication. This is used by systems that continuously validate the user's identity. This is often done with proximity cards or other devices that continuously communicate with the access control system. If the user walks away from the desktop and steps outside the range of the access control detector, the system locks the desktop. Then you have asynchronous tokens. The asynchronous token is the second of two types of token-based devices. It looks like a credit card-sized calculator. The authentication server issues a challenge number that the user enters. The token computes the response to the value provided by the authentication server. The user then replies to the server with the value displayed on the token. Many of these systems also protect the token from misuse by requiring the user to enter a PIN along with the initial challenge value. An asynchronous token device uses challenge response technology that involves a dialogue between the authentication server and the remote entity that is trying to authenticate. An asynchronous token device uses challenge response technology that involves a dialogue between the authentication service and the remote entity that is trying to authenticate. This requires a numeric keyboard. This figure shows an asynchronous token challenge response process. Look at number 1. Here a user requests access via an authentication server. For example, the user ID. Number 2, the authentication server issues the challenge number to the user. Moving to number 3, the user enters challenge numbers with PIN and smartphone. Moving to number 4, the smartphone calculates a cryptographic response, which is a password. The user sends the password to authentication server number 5. And in number 6, the authentication server grants access to the application server. Biometrics can be used for identification, which is physical biometrics, and authentication, which is logical biometrics. Biometrics involves measuring various unique parts of a person's anatomy or physical activities. The common biometric measures you'll learn about in this lesson can be broken into two categories. Either static, for example, physiological measures, which is what you are. Physiological biometrics include recognizing fingerprints, iris granularity, retina blood vessels, facial looks, hand geometry, and so on. Or dynamic, for example, behavioral measures. This is what you do. Behavioral biometrics include voice inflections, keyboard strokes, and signature motions. Note that biometrics of this type are sometimes separated into their own category, which we call authentication by action. There are 3 primary concerns with biometrics. First is accuracy. Biometric devices are not perfect. Each has at least 2 error rate associated with it. The false rejection rate, which we call FRR, is the rate at which valid subjects are rejected. We have another one called the false acceptance rate, which is FAR, and that's the rate at which invalid subjects are accepted. There's a trade-off between the FRR and the FAR. The point at which the 2 rates are equal is called the crossover error rating, or the CER. You want to write that down. The CER is the measurement of the system's accuracy expressed as a percentage. In practice, biometric devices that protect very sensitive resources are generally configured to accept a high level of false rejections. Systems that protect less sensitive resources may grant access to potentially unauthorized personnel so as not to excessively slow down access. Next is acceptability. Certain biometric measurements, such as retinal scans, are more objectionable to some users than other biometric measurements, such as signature dynamics. It is important to note that if users are not comfortable using the system, they may refuse to submit to it. And finally is reaction time. Each biometric device requires time for the system to check an identity and give a response. A system that takes too long may not work. For example, consider facial recognition at security airports. If the system needs 5 minutes to identify a passenger, then passenger checkpoint lines will become far longer than they already are. Reaction time must be fast for most checkpoints. Anything too slow hinders productivity and access. Here are the different types of biometrics. I'm not going to go over each one of these. You can find them in your book on page 149. You should familiarize yourself with these. Next is authentication by location. A user's physical location can also be a strong indicator of authenticity. Location can provide additional information to suggest granting or denying access to a resource. For example, suppose a user provides a PIN along with a debit card number to a card reader. The card reader is located in a fuel pump in Topeka, Kansas. However, the IP address of the user providing the PIN is located in Tampa, Florida. The separate locations may raise enough suspicion to deny the necessary access to the funds. On the other hand, a taxi scheduling application may use the customer's smartphone location to validate that a request for a pickup is valid. As with other methods, authentication by location should only be used in multi-factor authentication. And last is authentication by action. One of the newest authentication methods is based on a user's action. There's confusion as to whether this is really a subset of biometrics. You've already learned the details of biometrics in the biometrics section of your book, but be aware that authentication by action is sometimes set aside as a separate authentication category. It is also called something you do. This type of authentication stores the patterns or nuances of how you do something. The most common use is to record typing patterns. Most people type with predictable speed and pauses between different keys. These patterns can be stored and used during authentication. A single sign-on strategy allows users to sign on to a computer or network once and have their identification and authorization credentials allow them into all computers and systems where they are authorized. They don't need to enter multiple users' IDs or passwords. SSO reduces human error, which is a major part of system failures. It is highly desirable but difficult to put in place. You can learn about advantages and disadvantages of SSO in your book on page 151. Examples of SOO processes include the Kerberos, Sesame, and LDAP methods. You can learn about each one of these in your book on page 153. At this point, you've learned about how users are identified, which is step 1, authenticated, which is step 2, and authorized, which is step 3. Now it's time for the last part of the access control process, and that's accountability. Accountability is tracing an action to a person or process to know who made the changes to the system or data. This is important for audits and investigations as well as for tracing errors and mistakes. Accountability answers the question, can you hold users responsible for what they do in the system? First thing we have are log files. Log files are a key ingredient to accountability. Log files are records that detail who logged onto the system, when they logged on, and what information or resources they used. In the early days of computing, logs were used on systems that were shared by several users. It was necessary to charge users for their time using the systems, so logs track that data. Log files were also used by companies such as CompuServe and AOL when internet use was charged by the hour. On today's networks, most billing is either a fixed fee or based on bandwidth usage. Time-based billing has become uncommon. Logging now is used for more than just billing. It's also a valuable tool to detect, prevent, or monitor access to a system. Next is monitoring and reviews. One of the main reasons to track user access activities is to detect questionable actions and respond to them. That means you should use software that monitors your activity logs and generates alerts when it finds suspicious activity. Continuous monitoring is an important part of a secure access control system, but not all suspicious activity is obvious. At times, the only way to detect account policy violations is to review users' actions over a period of time. Your account policy should include a requirement for periodic user account reviews. Such reviews help to validate that user access definitions are correct. They also help to find inappropriate activities or excessive permissions. Of course, every policy should outline steps to take to respond to any violations. Knowing how to respond to violations is just as important as finding them in the first place. Next is data retention, media disposal, and compliance requirements, which I'll cover at the same time. Many current laws require that organizations take measures to secure many types of data. The Health Insurance Portability and Accountability Act, also known as HIPAA, is one example of legislation that requires data security. It protects the privacy of personal health data and gives patients certain rights to that information. Another example is the Fair Credit and Accurate Transactions Act, or FACTA. FACTA requires any entity that keeps consumer data for business purposes to destroy personal data before discarding them. These and similar laws require the protection of privacy data with proper security controls. These laws outline the right ways to handle, store, and dispose of data. If these rules and regulations aren't followed, intruders can, for example, simply dive into dumpsters to get sensitive data. For media disposal, most security attention tends to focus on securing active resources. Many organizations tend to overlook the fact that data still exists on retired media or even in the trash. It is important to ensure that no data leak out of an organization on discarded media. Media disposal requirements prevent attackers from getting their hands on files, memory, or other protected data. Many organizations allow media to be used again, but only if the original data were not sensitive. As an extreme example, media that contains plans for a nuclear weapon would not qualify for reuse. You could violate the law if you do not destroy data before discarding the media. Some of the most visible types of technical controls are those protecting access to computer resources. Most users have encountered access control restrictions. For example, any user who has typed an incorrect password should have been denied access. Because there are many ways to restrict access to different resources, it is helpful to refer to models to help design good access controls. There are several formal models of access control, including the following. You have discretionary access control. With DAC, the owner of the resource decides who gets in and changes permissions as needed. The owner can give that job to others, though. Next is mandatory access control, or MAC. With MAC, permission to access a system or any resource is determined by the sensitivity of the resource and the security level of the subject. It cannot be given to someone. This makes MAC stronger than DAC. Non-discretionary access control are closely monitored by the security administrator, not the system administrator. And rule-based access control is a list of rules maintained by the data owner, which determines which users have access to objects. Let's take a closer look at discretionary access control. The common criteria define discretionary access control as follows. It's a means of restricting access to objects based on the identity of subjects and/or groups to which they belong. The controls are discretionary in the sense that a subject with certain access permissions is capable of passing that permission, perhaps indirectly, onto any other object. Under discretionary access control, we have operating system-based DAC. Operating system-based have primary control or responsibility for controlling access to system resources such as files, memory, and applications. One of the main jobs for security administrators is to maintain access controls. Access controls are effective when they ensure that only authorized users can access resources. They are efficient when they ensure that users can access all the resources they need. Creating access controls that are both effective and efficient can be challenging. Organizations must decide how they would design and maintain access controls to best meet their needs. Here are a few points that organizations must consider in developing access controls. First is access control method. Today's operating system contains access control settings for individual users, like rule-based, or for groups of users, like role-based. Which method you use depends on the size of your organization and the way specific access rights need to be for individuals or roles. Second is new user registration. When new users are brought into an organization, their user accounts must be created. This can take a lot of time. It must be done quickly, however, so new people can do their jobs. User registration must be standardized, efficient, and accurate. And the third bullet is periodic review. Over time, users often get special permission to complete a particular project or perform some special tasks. These permissions need to be reviewed from time to time to make sure they stop when they are no longer needed. This review solves problems of compliance and auditing by making sure people can access only required areas. Let's move to application-based DAC. Application-based DAC denies access based on context or content. The application presents only options that are authorized for the current user. For example, an automatic teller machine or ATM menu limits access by displaying only the options that are available to a particular user. You can apply security controls using these types of DACs based on user context or resource contents. In a context-based system, access is based on user privileges as defined in the user's own data records. This is usually granted to persons acting in a certain job role or function. In a content-based dependent system, access is based on the value or sensitivity of data items in the table. This system checks the content of the data being accessed and allows, for example, a manager of Department A to see employee records for personnel that contain an A in the department field, but not records containing any other value in that field. And last is permission levels. Permission levels indicate a subject's right to a system, application, network, or other resources. In a DAC environment, the authorization system uses permission levels to determine what objects any subject can access. Permission levels can be user-based, job-based, group-based, role-based, project-based, or task-based. Mandatory access control is another method of restricting access to resources. You determine the level of restriction by how sensitive the resource is. This is represented by a classification label. Individuals must then be formally authorized, for example, obtain clearance to access sensitive information. Security policies defined for systems that are used to process classified information or any other sensitive information must include provisions for enforcing MAC rules. That is, they must include a set of rules that controls who can access what information. Under mandatory access control, the system and the owner jointly makes a decision to allow access. The owner gives the need to know element. Not all users with a privilege or clearance level for sensitive material needs access to all sensitive material. The system compares a subject and object labels that go with the terms of the Bell-LaPadula confidentiality model, which is going to be covered later in this lesson. Based on that comparison, the system either grants or denies access. Temporal isolation, the third bullet, restricts access to specific times. It first classifies the sensitivity level of objects, then it allows access to those objects only at certain times. Temporal isolation is often used in combination with role-based access control. You may see temporal isolation more commonly described as time of day restrictions. Regardless of the term used, they both simply mean restricting access to specific time windows. In non-discretionary access control, access rules are closely managed by the security administrator. They are not managed by the system owner or by ordinary users for their own files. Non-discretionary access control can be used on many operating systems. This strategy is more secure than discretionary access control. The system doesn't rely on any user's compliance with organization policies. For example, even if users obey well-defined file protection policies, a Trojan horse program could change the protection to allow uncontrolled access. This kind of exposure isn't possible under non-discretionary access control. Security administrators have enough control in non-discretionary access control to make sure sensitive files are write protected for integrity and readable only by authorized users to preserve confidentiality. The chances that a corrupted program will be used are reduced because users can only use programs that are expressly allowed to run. Non-discretionary access control helps ensure that system security is enforced and tamper-proof. If your organization needs to manage highly sensitive information, you should seriously consider using non-discretionary access control. It does a better job of protecting confidentiality and integrity than DAC does. The data owner, who is often the user, does not make access decisions. This allows you to enjoy some of the benefit of MAC without the added administrative overhead. In a rule-based system, access is based on a list of rules that determine who should be granted access. Data owners make or allow the rules. They specify the privileges granted to users, such as read, write, and execute. The success of rule-based access control depends on the level of trust you have with the data owners. This type of access control pushes much of the administration down to the data owner. For technical and security conscious users, this type of access control tends to work well. It doesn't work as well in environments with many users or where users lack the necessary technical skills and training. This slide shows how individual rules control each user's access permissions. Most operating systems provide several options to associate lists or permissions with objects. These lists are called access control lists. Different operating systems provide different access control lists enabling options. For example, Linux and OS X have read, write, and execute permissions. These can be applied to file owners, groups, or global users. Windows have both share permissions and security permissions, both of which enables access control lists to define access rules. Share permissions are used to get resources by a network share. Security permissions are used to get resources when the user is logged on locally. Some Windows permissions include the following. When you have share permissions, you have full, change, read, and deny. And when you have security permissions, you have full, modify permission, list folder contents, read, execute, read, write, special, and deny. In both share and security permissions, deny overrides every other permission. But what happens if no ACL exists for a resource? Most authorization systems use implicit deny, which means that if no rule to grant access exists, access is automatically denied. This approach is more restrictive but more secure. This figure shows an access control list, for example. Another type of access control is role-based access control, or RBAC. An RBAC policy bases access control approvals on the jobs the user is assigned. The security administrator assigns each user to one or more roles. Some operating systems use groups instead of roles. The resource owner decides what roles have access to what resources. Microsoft Windows uses global groups to manage role-based access control. This figure shows RBAC. This figure shows how content-dependent access control can protect data. Content-dependent access control is based on what is contained in the data. It requires the access control mechanism, which is the arbiter program, which is part of the application, not the operating system, to look at the data to decide who should get to see what. The result is better granularity than other access control methods you have. Access is controlled to the record level in a file rather than simply to the file level. The cost of doing this is higher, however, because it requires an arbiter program. The arbiter program uses information in the object being accessed. For example, what is in the record? The decision usually comes to a simple if-then question. For example, if high security flag equals yes, then check security level of user. Managers might have access to the payroll database to review data about specific employees, but they might not have access to the data about employees of other managers. With a constrained user interface, the user's ability to get into or interface with certain system resources is restrained by two things. The user's rights and permissions are restricted, and constraints are put on the device or program providing the interface. A device such as an ATM or software such as on a public access kiosk browser lets users reach only specific functions, files, or other resources. It limits their access by restricting their ability to request access to unauthorized resources. For example, some systems gray out icons that are not available. Several methods of constraining users are as follows. First are menus. One way to keep users out of certain data is to simply not give them any idea that the data exists. When the user logs on, the menu that comes up does not include closed areas. Next are database views, also called view-based access control or VBAC. This approach is often used with relational databases. The database system creates a view for each user that limits the data that he or she is able to see. Although there may be more data in the database, the user can only access the data defined in the view. Many current databases provide a way to partition a database into several slices. This feature, called multi-tenancy, allows different groups of users to access a database without being able to access each other's data. This ability is important to organizations that want to use the cloud for their shared application and databases. Next are physically constrained user interfaces. The user interface mechanism represents the user with a limited number of options. For example, an ATM offers only a certain number of buttons to push. This makes it a physically constrained user interface. And last is encryption. This approach constrains users because it requires them to have the decryption key to reach or read information stored on the system. Encryption also hides information such as credit card details for the user. Other access control methods that I won't cover here are in your book, which are Bell-LaPadula, Bieber Integrity Model, Clark-Wilson, and Brewer-Nash. Again, these will be covered in your book, so for read up on these inside the text, page 165, 166. Let's look at the effects of breaches in access control. Your failure to control access can give your opposition an advantage. That opposition might be a military force, a business interested in competitive intelligence, or even your neighbor. This slide contains a list of details of some of the losses that can occur. You can have disclosure of private information, corruption of data, loss of business intelligence, danger to facility staff and systems, damage to computers, and failure of systems and business processes. Not all incidents have the same effect. Some are easier to spot than others. For example, losses due to disclosure of business secrets, including business intelligence, often go unnoticed for quite some time. Losses due to corruption of data might make a database and all its backups useless by the time it's discovered. Data corruption can easily cause failures in systems and business processes. This slide contains a list of threats to access controls. The challenges of access control come in many different forms. This list can never be complete. New threats evolve all the time. An example is the peer-to-peer or P2P risk, in which P2P users share their My Documents folder with each other by accident. This can expose sensitive documents to other users. I'm not going to go over each one of these threats to access control. You can find them in your book on page 167. You have seen some of the ways attackers can compromise access controls, or at least read them in your book. But what happens if an attacker is successful? What is the impact of an access control violation? An access control violation can have the following harmful effects on an organization. It could be loss of customer confidence, loss of business opportunities, new legislation and the regulations might be imposed on an organization. You can suffer bad publicity, more oversight from agencies, and financial penalties. As you have learned about access control, you probably have thought about how to store all the information needed to support access control decisions. You need to allow users to register and provide valid identification and authentication credentials. Then you have to define access permissions, associate those permissions with users, and allow for maintenance. In fact, all these tasks are part of credential management. Credential management systems provide the ability to collect, manage, and use the information associated with access controls. But managing credentials is only the first step. It is also necessary to manage permissions and access rules. In a dynamic system with many users, this task can easily become overwhelming. Microsoft offers a feature called Group Policy to help administrators manage access controls. A Group Policy Object, or GPO, is a collection of settings for users or computers that can be applied efficiently to a group of computers. GPO features allow Windows administrators to define settings in one place that can easily apply to many other users and other computers as well. Centralized access control is an access control approach in which a single common entity, such as an individual, department, or device, decides who can get access to the systems and networks. The access controls are managed centrally rather than at the local level. Owners decide which users get to which objects. The central administration supports the owner's directive. Centralized authentication services are applied and enforced through the use of authentication, authorization, and accounting, which is the AAA servers. The benefit of using AAA includes the following. It involves less administration time because users' accounts are maintained on a single host. It reduces design errors because different access devices use similar formats. It reduces security administrator training because only one system is learned. It improves and eases compliance auditing because all access requests are handled by the system. And it reduces help desk calls because the user interface is consistent. Here are the types of AAA servers that are available. I'm not going to go through each one of these. You can find them in your book on page 169 and 170. Another access control approach is to handle access control decisions and administration locally. This approach is called decentralized access control. That means access control is in the hands of the people, such as department managers who are closest to the system's users. Access requests are not processed by one centralized entity. On one hand, decentralized access controls often results in confusion. Why? Because it can lead to loss of standardization and to overlapping rights. This might cause gaps in the access control design. On the other hand, a decentralized approach eliminates the single point of failure problem. It ends the perception that a central controlling body cannot respond effectively to local conditions. The two most common examples of decentralized access control are the Password Authentication Protocol, also known as PAP, which uses clear text username and passwords, and the Challenge Handshake Authentication Protocol, also known as CHAP. CHAP is more secure than PAP since it hashes the password with a one-time challenge number to defeat eavesdropping-based replay attacks. As the explosion in the number of smartphones and tablets continues, so does the need to provide secure access. Access controls for mobile devices are evolving. There are two relatively new approaches designed for mobile use. The Initiative for Open Authentication, also known as OATH, is an ongoing effort to develop a reference architecture for strong authentication. Over 30 organizations contribute to the OATH project. OATH developed several standards to support mobile device authentication. The first is called HMAC-based one-time password, or HOTP. HOTP provides a very secure method to authenticate a user using an authentication server. The other one is time-based one-time password, or TOTP. And that's an example of HOTP. It combines a timestamp with a hash value to reduce vulnerability to replay attacks. OATH proposes a reference framework that supports both centralized and decentralized access control models. One of the most visible security concerns is that of privacy. The growing awareness of identity theft and the importance of protecting privacy have resulted in new laws and standards to ensure privacy. Personal privacy is only one aspect of this growing issue. Organizations are becoming more and more aware of the dangers of privacy violations. Organizations often monitor their staff electronically because they're worried about things like liability in harassment suits, skyrocketing losses from employee theft, and productivity losses from employees shopping and performing other non-work related tasks online. Companies must clearly communicate their policies for what is acceptable for employees to do and what will be monitored. In many cases, employees cannot expect any privacy while using corporate systems. An organization's acceptable use policy is an important document to set the appropriate expectations for, among other things, privacy. In 2007, the American Management Association made a survey titled Electronic Monitoring and Surveillance, and it found that 73% of organizations use technology tools to automatically monitor email, and 40% of employees assign an individual to manually read and review email. In addition, 66% monitor internet connections, while fully 65% of companies use software to block connections to inappropriate websites. Monitoring the workplace includes, but is not limited to, the list that you see on this slide. One of the strongest trends in enterprise development is incorporating shared services into computing environments. Cloud computing is the practice of using computing services that are delivered over the network. The computing services may be located within the organization's network or provided by servers that belong to some other network. There are several cloud models to meet the needs of diverse user environments. Cloud services generally fall into one of the following categories. First, you have a private cloud. All the hardware and software required to provide services, including the network infrastructure, is operated for a single organization. The components may be managed by the organization or by a third-party provider. The actual infrastructure can be located within the organization's network or outside of it. Next is the community cloud. This type of infrastructure provides services for several organizations. The different organizations share the cloud environment and use it for their specific needs. The infrastructure can be managed by one of the participating organizations or by a third party. Third is the public cloud. This type of cloud infrastructure is available to unrelated organizations or individuals. Public clouds are generally available for public use and are managed by the third-party provider. And last is the hybrid cloud. This type of cloud infrastructure contains components of more than one type of cloud, including private, community, and public clouds. Hybrid clouds are useful to extend the limitations of more restrictive environments. They often are used to provide resiliency and load balancing by distributing workload among several infrastructures or segments. This slide contains some of the advantages and disadvantages of cloud computing. You might want to pause and take a look at this. So in this lesson, you learned that access controls are ways to permit or deny access to certain resources. Organizations use access controls to manage what staff can and can't do. Access controls specify who users are, what they can do, which resources they can get to, and what operations they can carry out. Access control systems use several technologies, including passwords, hardware tokens, biometrics, and certificates. Access can be granted to physical access, such as buildings or rooms, as well. Access can also be granted to information systems. You learned that the four parts of access control are identification, authorization, authentication, and accountability. These four parts create an access control process that can be divided into two phases: the policy definition phase and the policy enforcement phase. You also learn how you first need to decide who is authorized for access and what systems or resources they're allowed to use. Then you learn how access is granted or rejected based on the authorizations defined in the first phase. You also learn about the formal models of access control methodologies and challenges, and the effects of access control breaches. That is it for lesson 5, and I'll see you in lesson 6.